type of problems that we are going to solve in these two are the ones that have a solution with certain characteristics, in which one of the components is going to be added in order to change the final concentration. We need to calculate how much of these components must be added to change the characteristics of the solution. For example, here we have 200 liters of a solution that is 30% alcohol and 70% water. We need to calculate how much liters of water is going to be added to change the solution in order to have 20% alcohol and 80% water. So in next slide, we are going to solve this type of problem. It says how many liters of pure alcohol must be added to 20 liters of an alcohol solution that is 90% pure in order to obtain a solution that is 95% pure.
There are 20 liters of an alcohol solution that is 90% pure. It means that 18 liters are of alcohol and 2 liters are water. Now, let X be a number of liters that are going to be added to the solution in order to obtain a new solution that is 95% pure. Since the amount of water hasn't increased or decreased, then 2 liters of water represent a 5% of the new solution. Finally, solve for X. X equals 20. Letter C is correct.
Problem 5 says an alloy of gold and silver is 12.5% gold. How many pounds of gold must be added to 40 pounds of the alloy in order for the resulting alloy to be 30% gold?
Let X be a number of pounds of gold that were added to the 12.5% gold alloy. Since the amount of silver hasn't increased or decreased, the amount of silver represents a 70% in the new mixture. Therefore, 35 pounds of silver equals 70% of 40 plus X. Finally, solve for X. X equals 10. Choice D is correct. According to the picture, two solutions with different characteristics but the same ingredients are combined to form a new solution.
Problem 6 says how many liters of a solution that is 10% salt must be added to 25 liters of a solution that is 30% salt, so that the resulting solution is 15% salt.
Once the solutions are mixed, we get the following relationship. The percent of salt of solution 1 plus the percent of salt of solution 2 equals the percent of salt of the mixture. Now, let X be a number of liters of solution 1 and replace the area in the relationship already established. 10% of X plus 30% of 25 equals 15% of X plus 25, and finally solve for X. X equals 75 liters. Choice D is correct.
Next question says if 10 pounds of nuts that cost $2.30 per pound are mixed with 6 pounds of nuts that cost $1.5 per pound, what is the cost per pound of the mixture?
If the mixture problem is about cost, use the following equation. Price times amount equals cost. Once the products are mixed, cost 1 plus cost 2 equals the total cost. And let X be the cost per pound of the mixture. And replace data given in the equation. Finally, so for X, choice C is correct. 6 ounces of a fresh orange juice contains 180 calories, and 6 ounces of fresh apple juice contains 120 calories. If a mix of 12 ounces of these two juices contains 250 calories, how many ounces of the mixture is apple juice? So, first of all, according to this sentence, 1 pound of fresh orange juice contains every 6 ounces of fresh orange juice contains 180 calories. So we can do the following. Every 1 ounce of fresh orange juice contains 30 calories. And according to this sentence, 6 ounces of fresh apple juice contains 120 calories. 1 pound of fresh apple juice contains so it will be kind of the same. 1 ounce of fresh apple juice contains 20 calories. Therefore, let the 12 ounces of these two juices contain X ounces of orange and Y ounces of apple juice. Once the juices are mixed, we get the following relationship. The number of calories in X ounces plus the number of calories in Y ounces equals the total number of calories, which is 250. So finally we get 30 times X plus 20 times Y equals 250. We can divide everything by 10. 0, 0, 0, 0, 0, and 0. And substitute X for 12 minus Y. 3 times 12 minus Y plus 2 times Y. And finally solve for Y. 36 minus 3 times Y plus 2 times Y equals 25. And finally 5 equals 11. Choice D is correct. A recipe of 8 pounds of a special food requires 5 pounds of substance A and 3 pounds of substance B. If there are 135 calories in 2 pounds of substance B and 29 calories in 3 pounds of substance B, how many calories are there in 32 pounds of the special food? Now, first of all, if a recipe of 8 pounds of special food contains 5 pounds of substance A and 3 pounds of substance B, how many pounds of each substance contains 32 pounds of the special food? Well, for every 8 pounds of special food, there are 5 pounds of A and 3 pounds of B. Therefore, in 32 pounds of the special food, which is 4 times the original receipt, we get 4 times A and 4 times of B. So we get 20 pounds of A and 12 pounds of B. Now, if there are 135 calories in 2 pounds of A, then in 20 pounds there must be 10 times 135, which is 1,350. Now, if there are 29 calories in 3 pounds of B, then there must be 29 times 4 calories in 12 pounds of B, which is 116. So this is 6 and 6 and 4, 1,466 calories in 32 pounds of the special food. Choice D is correct.